Hello and welcome to Section 2 of Learning Computer Vision in Python 3. For this project, we're going to be covering handwritten digit recognition with scikit-learn and TensorFlow. Here we're going to learn how machine learning can be applied to computer vision projects. And we're going to learn a couple different ways, a couple different models with a couple different Python modules, scikit-learn and TensorFlow. And we'll see, pros and cons of each approach, and you'll learn some techniques that you can apply towards your own projects. So, okay, let's get started. Talking a little bit about machine learning in general, probably heard of it at least a little bit. In this case, we're going to be covering supervised machine learning in particular, wherein we have a bunch of examples of what we want to accomplish. So rather than explicitly telling the computer what we want, we give it examples. So we have a bunch of labeled images, in this case handwritten digits, so 0 through 9, and we have labels that were created by humans of what those digits are supposed to be. So rather than hand coding features and all that and explicitly telling the computer what the algorithm is, we are going to construct a model where we take those inputs, optimize some sort of function, optimize like a set of variables, and we're going to train the computer to put the outputs to be what we want it to be. So if we have a handwritten 0, it'll output a 0, 1, 2, 3, and so forth. Handwrite a 9, puts a 9. So that's the general paradigm of machine learning. And we're going to cover 3 different algorithms here of accomplishing that. So let's start running some code. So first thing, if you want to follow along with this, is open up your Jupyter notebook, Computer Vision with Python 3-digit recognition. Just do that the way we learned in the previous section. And okay, start here with a fresh notebook. We're going to select this first cell here, Control Enter. This will take just a few seconds to run. And we're going to import our essential modules like NumPy, which is, the foundation of numerical computing with Python. Like all images and signals in general are going to be NumPy arrays. This is true whether you use NumPy, SciPy, OpenCV, TensorFlow, and so forth. We're going to import PyPlot, so that we can visualize what we're doing. We're going to use a little bit of OpenCV just to convert some images, and we have a few other helper modules which will help us. And of course, we're going to use scikit-learn, which is abbreviated sklearn in the actual module, and we're going to import a support vector machine as well as some tools that will give us our metrics, which tell us how well things have actually worked. And we're going to import TensorFlow, and we're going to use the convention where we're going to abbreviate TensorFlow as TF. And we're going to get our data from TensorFlow, which I'm going to talk about right now. So digit recognition is such a common thing in computer vision, and machine learning packages like scikit-learn and TensorFlow actually have built-in functionality for getting it. So you don't have to manually, go to a website and so forth and download it and then, write the lines of code that download it from, your folder or whatever. It's taken care of for you. So scikit-learn actually has like a good number of inbuilt data sets, some for computer vision, some for others. So it does have a digit example. You can see what other data sets are available in this. Do datasets dot. Uncomment that. I'm using Control/ to do this. Datasets stat. Okay, so now we have a list of inbuilt data sets. So like, for example, you want to know like California housing prices, like you want to estimate housing prices based on things like square footage and number of bedrooms in the house. There's a data set for that. Some of this is image data, some of it's not. Like the low digits here is image data. There's a whole bunch of other stuff. So this might be something you want to check out if you want to experiment with different machine learning. But the low digits one, we could use this, and I have some code here that shows what this does. Like here, for example, I load an example image. This is just the first image in the set. So digits equals datasets.load digits. Then the data is actually stored in images. And what that is it's an array of examples, and each one is an 8 by 8, kind of handwritten digit image. So, we plotted this here with plt.imshow, and we can see it. And this is all fine, but I like to work with slightly higher resolution examples, that we're going to see from MNIST in just 1 second. So just thought you should be aware that this is here. It's a little computationally faster in order to use these because they're smaller images, but we're not going to for here. If you want to pre-process these images, these are stored in 8x8. Machine learning, generally you have to convert it to a 1D array. You can do that easily using the reshape function right here, which will output just, instead of 8x8, you get a 1x64 array, as you see right here. Okay, so what are we actually going to use? So we are going to use MNIST data, which comes from this website right here. This is a fairly standard data set. TensorFlow is nice enough to provide some functionality for just getting that data. Again, so you don't have to go onto the website and manually download it. So we need to specify a data directory to save the data to. So just create this temp directory and TensorFlow and so forth. And this will be fine, regardless of what operating system you're running on. And then we have this input data, which we imported from TensorFlow, and read data sets. And so we're going to do that. And if you don't already have it, it will download these gzip files. And if you do already have it, it just reads from these gzip files. And it stores this in this MNIST, MNIST. I'm not sure how people pronounce that, but it will store it in this variable right here. So let's understand the data before we actually dive in and do some actual machine learning. So we have this variable, the MNIST, and it's already separated into training and testing data. So with machine learning, you don't want to train on all of your data. You don't want to build your model with all of your data because then you won't know how well it's going to handle new data, examples that it hasn't seen before. So what you want to do is split it into training data and testing data. So the training data is going to build a model and the test data is going to validate it. So this is already done for you just with these variables here. So we load train data from train images. We're going to see what the shape is to understand this. In case you need to know the number of samples, we can extract that just from the shape output. Again, this is a NumPy array, so all NumPy functions and features are there. And then the train labels, I should mention here, this one hot feature, this means get the labels in terms of one hot vectors, which means instead of being labeled with a numeric, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to be an array of mostly zeros. It's going to be an array of length 10, where everything is 0 except for one thing, which will be a 1. So if you had 0, 1, 0, 0, 0, 0, so forth, that would represent a 1. And if it were a 9, it would be all zeros until the last one, which would be a 1. So it's one way of, useful way for machine learning of labeling an output. So this is the way we got the data, and we're going to be using that. It's more helpful for when we actually use TensorFlow, but for scikit-learn, it actually does need the numerics. But we can convert that in one simple line here. So we just see where the training label equals 1, and we extract that, and we create an array of those values, and that will give us our training labels. So 1D array corresponding to the number of examples, which contains the actual output of each one. So let's execute this. We'll see just an example. I picked example 1, 2, 3, 4 out of our 55,000. So with this first digit in the tuple of train data.shape represents, we have 55,000 training examples. The 784 is the number of pixels in the image, and that's because these are 28 by 28 square, so 28 by 28, 784. So that is our data set. 55,000 examples, 784 pixels, or what we call features. And then the train labels is going to be of length 55,000, and just the other dimension is just 1, because it's just that. Here's an example. This was 9, it looks like. You can load example 1000. Okay, it's a 6. And then this data already comes in 1D array, so that was why I used the reshape here and passed the 28 by 28 tuple. in order to convert it to an actual image that we can see. Okay, great. So our data is loaded and processed in a ready-to-use form, so we can actually begin actual machine learning.